Okay, based on previous lectures, I hope everybody understand how the memory works. So how actually when you declare some variables, from that variables, how actually it had been processed to allocate some memory location inside your computer memory. So okay, before we discuss more about pointer, now let's take a look at this website, okay, cPointer. And then before we discuss about the pointer, in C programming, one way or one operation that you can use to know what is the memory address that allocate for your variable, where the variable that you declare in your program, is by using what we call as some unary operation, which is using this what we call as a ampersand operator. Okay, if you find some information, the information about this operator from other sources, some call it as a address operator. Okay, it's a single AND only, ampersand. So ampersand is a single AND. It's a different from the AND operation, because in C programming, if you want to do AND operation, you need to use ampersand two times, and so that is the AND operation. But if you using only single AND, that is called as well as ampersand operator, or in some other sources is called as address operator. This is the operation that you can done in your variable in C programming if you want to find out the address of your variable that have been allocated for you when you run the program. So now maybe we can discuss some example that you will know what happens when you apply the address operator, or also known as ampersand operator. Okay, so it's of course that's why I like about this website. You can just if you don't understand about the explanation, you can just you copy this one and then you paste into your online compiler, then you will see what will happen. Okay, I just copy this code into our online compilers. Okay, so this is the code. So yes, you can see that this is just showing you example how to know the address of your variables. In this program, we have two variables named as var1 and var2. This one is an integer and this one is array of char. Okay, you have a array of char, the dimension is 10. And then if you want to find out what is the address of this memory, I'm sorry, what is the address of this variable allocate for you in this program, then you just can use a function print to print the address. As you can see that we are using this AND or ampersand or the address operator. Okay, in this lecture, let's just call it as an AND. Okay, it's more simple for us to discuss. So just the purpose of this AND operate symbol is address operator, where you want to obtain the address of this var1, and this one is to obtain the address of your var2 inside this program. When you run the program, where is the variables or the memory location reserved for var1 and var2, it's to obtain that address you need to use this symbol. So if you run this program, okay, before that I just forget to explain. Here is another thing, something new for you, which is %x. So if you Google about %x, is actually if you want to display anything in hexadecimal, then you need to use a %x. Okay, again, the one that you familiar is %d, %f. Okay, %d is for decimal, %f is a floating numbers format. But if you want to print something in hexadecimal, then you need to use a %x. So again, because in computers architectures, address is always represent in hexadecimal. That's why we try to display it in %x. So as you can see, after we run this program, Okay, you can find out address for var1 is this one, address for var2 is this one. If I run it again, you will find out, will you get the different address there. Okay, I run again, you get different address. And then if I run it again, I get a different address. That this is the one that I mentioned before in the previous lecture, where you see that it depends on which address is free inside your computer, because now I open a lot of application like Firefox, PowerPoint, Word document, and so on. So all this application also requires some memory to run it. So that's why when you run this C program, it will the computer or the CPU try to find the address where that location is free from other application or other that address is not allocated by any application, the existing application. So if they find out that memory location, then we reserve that location for you. So that's why even if you repeat too many times, what I mean is that if you run several times, you find out the different address appear here, means that is what I mentioned before. We don't know what is the address of the variable that we have declared, because in general computer we decide, okay, it depend on which memory location is still available or still empty, or is still not allocated for any other application. Okay. Okay, what another things that I will like to highlight here, of course, if you display it in hexadecimal, it's okay. Again, if just imagine that if I run one time, okay, that is the memory locations there. So in other words, if we go back to to our programs there, okay, to our okay, the things that I want to highlight here, I don't want to run it again. Otherwise, if I run it again, the address will different. It depend on the CPU will decide. But based on this current running, you will find out, okay, in this case, the var1 address is this one, okay, and then the address for var2 is this one. So if I try to draw back, imagine this is your computer memory, and I try to write back all the address, involved address, you will find out, okay, this is the address of your var2, and this is the address of your var1, okay, in hexadecimal. Again, this is hexadecimal number. This 0x only show that this is just a symbol, show that this number is hexadecimal. Okay, so I just give some notation there based on this running. Okay, this is var2, this is var1. Okay, and again, what is var2? var2 is a variable with integer data type. So again, integer data type required 4 byte. So meaning that this is 4 byte. I'm sorry, let's use green there, 4 byte. Okay, so even integers required 4 byte, the first address, the address that represent the first byte in that memory is actually represent the var2. Okay, that's the things that you need to remember. Okay, in general, this address is actually represent the first byte that represent the var2. Even the var2 here is integer and it's required 4 byte, so it's go into, this is the memory required for you. You need 4 byte there, means that is go up into 39. Okay, this is an hexa. Remember, this is in hexadecimal, so it should be 30A here, and then one is 30B. So from 38 to 3B here is reserved for var1, but the first address actually represent the address for this var1. So however, for var2, you will realize that var2 is char, and it's an array of char, and one char is actually 1 byte. Okay, one char is 1 byte. So the array of char with dimension of 10, you require 10 byte. So that means you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that these memory locations there, okay, have been reserved for var2. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 byte. So this red location is for var2, this green location is for var1. So it's just you know, the memory location between var1 and var2 is just beside. Okay, var2 is beside var1. Okay, in this program. So of course, because this is the location which is free, so and it's adequate to store these two variables, so that's why it's put it in, you know, in next var1 is next to var2. So that is how you find out how actually this memory have been generated. Okay, again, if I run it second time, of course I get another address, but you will find out the difference between this address and this address is 10. Okay, if you convert this address and this address into decimal, if you minus between this and this is 10. Because why? Because the first the var2 required 10 byte. So of course after 10 byte, if after 10 byte the next memory cell is empty, then it will reserve for var1. Okay, you can just experiment that, okay, by changing this one. Okay, you just change it into decimal. You don't want to display in hexadecimal, you put it as a decimal. You will find out the difference between this address and this address is 10. Okay, see, okay, 76 minus 66, 10. I run it again. Okay, 26 minus 16, 10. If I run it again, 92 minus 82, so it's 10. The difference is 10. Why? Because of the var2 is a char array with dimension of 10, which requires 10 byte. So that's why the next or the adjacent memory location will be reserved for var1, which is next to var2. So that is normal.